This tunnel is only 1.4 miles long, yet replacing it is part of a project currently estimated to cost around $6 billion. So how did a tunnel this short become one of the biggest infrastructure projects in the entire US? To understand that, we need to go back over 150 years. The tunnel was constructed all the way back in 1873 when American railroads looked vastly different and were of vastly different standards from what they are today. At this time, this was cutting-edge revolutionary infrastructure, but the railroad that was built around it eventually became part of something bigger. Today, the tunnel sits on the Northeast Corridor, America's busiest rail route, connecting major cities from Boston to Washington, D.C., and handling well over 2,000 trains. And unlike when the tunnel was built, it now has to accommodate a huge variety of trains, from intercity passenger services like the Northeast Regional to commuter trains like the MARC and occasional freight movements from Norfolk Southern and CSX. That puts an enormous amount of demand on aging infrastructure that was never designed for modern railroad traffic. And the tunnel itself has become one of the system's biggest weak points. It isn't simply old. It has been exposed to over a century of weather, water, heavy train traffic, and structural deterioration due to neglected maintenance and the aforementioned factors. The tunnel has suffered from extensive cracking, corrosion, and vegetation growth, while water infiltration and flooding have become major concerns and deterioration accelerators, and the drainage system doesn't exactly make things easier. Storms and heavy rainfall can put additional stress on the tunnel. The drainage system was built according to the much older standard. That means severe weather can become more than just an inconvenience. It can directly affect the reliability of the railroad. But even on a perfectly normal day, there is another major problem. Speed. The railroad segments approaching the tunnel on both sides can comfortably support speeds of roughly 100 miles per hour. Inside the old tunnel, however, trains are limited to around 30 miles per hour due to its condition and tight curvature. So the tunnel creates a giant traffic bottleneck in the middle of a much faster, smoother railroad. A train can approach at high speed, only to brake and enter the tunnel and suddenly slow down dramatically. And because this is part of America's busiest rail corridor, that restriction doesn't just affect one train line. It can affect the scheduling and capacity of the entire intercity corridor. That's why simply repairing the existing tunnel isn't necessarily the best solution in this case. You could spend a huge sum of money rehabilitating a structure from the 1800s, and you'd still have some of the fundamental design limitations of the original design. Instead, the plan is to bypass it entirely. Amtrak plans to construct 2 new single-bore tunnels alongside the existing route called the Frederick Douglass tunnels. These will be built to modern engineering standards with improved drainage, structural systems, and protection against all kinds of weather-related problems that plague the existing tunnel. More importantly, they will allow trains to travel through this section at up to the full 100 miles per hour rating. That means the new route won't just be newer and more reliable, it removes the 30 mile per hour speed bottleneck entirely. And there's an interesting part of the plan. It doesn't involve demolishing the old tunnel either. The existing tunnel can remain available for freight operations while faster Amtrak and MARC services divert to the new tunnels for speed. So instead of forcing every type of train through the same aging infrastructure, the railroad can effectively separate the traffic by speed capability. Fast passenger trains get a modern high-speed route, slower freight trains can continue using the existing slower tunnel. And the railroad gains additional resilience because a failure or closure of one route doesn't necessarily mean the entire corridor has to shut down. But the price tag of the project is enormous. And that makes more sense when you consider what's actually being built. This isn't simply redoing an existing tunnel or punching a simple hole. The project involves major excavation on a new alignment, adequate ventilation, proper drainage, new electrical systems, signaling, track infrastructure, portals, and approaches, has to meet environmental requirements, and the challenge of constructing new infrastructure while the existing line is required to maintain open. There's also the cost of building something that's supposed to last for generations. The original tunnel made it all the way from 1873 into the 21st century. The goal of the replacement is to make sure the next generation of infrastructure doesn't become another century-old bottleneck like its predecessor. So this project isn't really about the length of the tunnel, it's about replacing a critical piece of infrastructure that has survived from the 19th century all the way to a completely different era. A tunnel that once represented the future of American railroading is now one of its biggest constraints, and the solution is essentially to build an entirely new railroad to bypass it.